Okay, hello everybody. We're going to start the workshop about extended instruments. We're going to see a little bit about what is an extended instrument, and then we are going to build a new one. Not a new one exactly, but we are going to learn about Arduino, about sensors, about MaxMSP. It's a really good software also for manage the data from the Arduino, and also how to use all this data from the sensor to control or to map our instrument to sound effects in Ableton Live. So first of all, I'm going to, okay, if you want to ask anything, you can do it in YouTube in the comments. So I will check it now and then. So no problem with that. So we're going to start. Maybe I will share with you some PDF I have here, just to see like a sum up about what it's going to be about. So okay, there we go. Okay, so the main title of core is extending your instrument, introduction to sensors as MIDI controllers. First of all, let's see what is a sensor actually. What are they and how can they be useful for us? A sensor is a device which detects or measures a physical property. That means that we have a lot of different sensors, and it depends on what we want to measure. So for example, I have this box with 37 sensor kits. I can show it here also. There, I think the camera is working. So you have a lot of different sensors, and you can measure a lot of different things. So first of all, we have to think about what do we want to measure. If we want to measure movement, proximity, or I don't know, temperature, I don't know, whatever. This is like a really big word, so it's up to you to choose what you want to measure. So if we use the sensors, why do we want to extend our instrument? There are a lot of possibilities using the sensors. Some of them is, for example, like creating a new instrument, or maybe use them as embodied controllers for your instrument. So it's similar to, for example, let me look for this. Okay, so let's do the screen, camera, webcam, wait, there we go. Okay, so if you have a controller like this one, you have a lot of different faders, knobs, even keys. So the sensors will allow us to control, for example, something as we change this fader, but instead only a fader. It could be the movement of the hand, or it could be the temperature of your room or the concert room, or it will be whatever, you know. It could be also something related to non-physical control, for example, your heartbeat. I mean, it's up to you. It's about your imagination. So let's check what people have done before really quickly, just to have an idea about possibilities. Okay, so here we have the really famous one. It's really experimental, but it's really amazing. The new interfaces. It's in Nîmes. It's a festival. As you can check, you can create any instrument you want. I mean, like movement of the hand with water, hand movement, dancers. This one is a famous one. It's called the React table. And of course, it's super complex. We are going to do today an introduction, and this is like a really, really famous instrument. And then, yeah, a lot of people have used it already. But of course, this is kind of the goal, right? I mean, we're going to start with a simple sensor, but you can expand the possibilities to reach this level. Also, I'm going to show you a piece. It is called Quantified Performer, and this is more about, wait, let me listen to it too. This is more about controlling your cello, for example, the sound of your cello with your heartbeat. So every time you have a heartbeat, you are going to amplify the cello, and this was done also with the heartbeat sensor. Let's see. So you can check every time the player has a beat in the heart, she can amplify and also trigger the visuals. So there are a lot of possibilities, and of course we are not going too deep a lot in this one, but you can also do installations. So to create interactive sound and visuals installations, you can map parameters of your installation with physical realities. This video from the Cave of Sounds by Tim Murray is super nice just to see all the possibilities. He talks also about different sensors they used for that.
And a gyroscope inside a sphere.
Which make sound.
Instruments. One uses an accelerometer and a gyroscope inside a sphere.
Which make sound. And for that reason I also call it a sonic sphere.
One of them is based on the theremin, and you trigger it by moving your hand near an aerial. Two are based on lights, one where you cast shadows using your hand.
It's a surface on which a light is shining, and you put your hands in between to make shadows on that surface.
So it's to trigger different notes.
Okay, so let's start also with how we are going to do it. First of all, I'm going to do an example, so it's going to be a bit fast. So I'm going to do all this path. I'm going to choose a sensor, then I'm going to put it in the Arduino, I'm going to run the Arduino code, and then the data is going to go to MaximSP, a software, this one we're going to see later. And we're going to manage the data, we're going to scale it, and then this data we're going to send it to Ableton, and we can map to the sound effects there. And then of course we're going to have the output. We can use all this path to control effects, but also we can use it to create an instrument, so it's also up to you. So first of all, okay, let me show you camera here. Okay, so I'm going to create like a simple instrument, okay, only with one sensor and one sound input. I'm going to do it like a percussion instrument, okay? Actually, this is going to be my box, and I'm going to do percussion with it. So my idea for the workshop, it was, okay, let's take this LDR sensor. Okay, let me show the camera. Whoa. This one, yeah. Okay, I don't know if it's focused a lot, but okay. So the LDR sensors, also I can show you here in the screen if you can see it there. This one, okay. You can measure the light on your room, okay. So if it is super light, it will give a lot of data, and then the other way around, if there is no light at all, it will give less data. So how can we get how much light we have in the room? So we take these sensors, okay, and then we put it here, the breadboard. Of course, we're going to see it later, little by little, how to connect and everything. You can see we have a resistor here also. So yeah, and then you connect all the cables to this, the Arduino. This is the hardware you need. Of course, you have the Arduino, and maybe this is like the usual option, but there is a cheaper one. It is called 𝘍𝘰𝘍𝗻. So for the people who wants to really go into it, maybe, and you don't want to spend like 30 euros at the beginning, with 𝘍𝘰𝘍𝗻 you can spend maybe 10 and you have it, okay? So you have the Arduino, then you connect it with USB, you connect it to your computer, and then let's see what you have to do in the computer. Let's go here. I will share now the screen. Wait. Okay, so now have all this material. I will send it to you if you are interested on it. Okay, I will create a link so you can download the Arduino code and also the patches if you want, so no problem with that. But as I said, let's do it quickly now and then we can go little by little. Let's hope the laptop can do it. So mainly what we're going to do now with Arduino is to read. Let's wait if it's open there. Okay, here we have it. Hope you can see it. Maybe I can put it like full screen. Okay, it's not super, but okay. So you have here the serial begin, then we can talk about that, and then I'm going to read the different sensors. I call it IR sensor, but of course it's not IR. This doesn't mind at all, but we will change it later. I'm going to read maybe not IR sensor 3 or anything, only I'm going to read the IR sensor 2 and sensor 1, okay? So first of all, I have to upload it to the Arduino with this button. Then I have to wait that it is compiling. Okay, and then we check really quickly if it is working. Okay, we have some data there. We can even do it in this way. Yeah, but I think it's going to be enough. As for that. Okay, let's check again. Yeah, so here we can see it is working properly. So now we open Max. Sorry for the laptop. Okay, maybe I will leave it open just to save some time later. Okay, so here we have the patch again. Now it is only an example, so don't worry too much. We are just going to see how could it work. Okay, so we open it and we have the data here. Okay, so this is the data we got from the Arduino, and then it's going here. Then we do a lot of scaling, and now what we have to do is the data we got at the final of this path, we are going to send it to Arduino. So here I say, okay, I want to send it from max 1. Okay, and then, sorry, we are going to send it to Ableton, not Arduino. Then we open Ableton. Okay, and in Ableton, oh, it's going slow. Okay, first of all, we just want to have the audio here. I have a microphone connected in the second one. Okay, so here we're getting the data from the microphone. Let's see if it works. Okay, if you see here the camera, it's a contact mic, okay? So I can get the sound from the percussion. So what I'm going to do now, just as an example, I'm going to put a reverb on it. I'm going to control how much reverb I want with this light sensor. Okay, so now we have the reverb. Let's check. I'm going to focus just in the first. Come on, one sensor read. Okay. Waiting for it. Maybe we should close this. Okay, now let's do it again. Let's check if it is working. Monitor. Okay, we have here the sequence. Okay, so now we will work on that to have a better data, but actually if we put our hand here, okay, you can see how these numbers goes lower or go higher. Okay, so this is what we are going to use. So we put the MIDI and we say here map MIDI, for example, to the delay time. Okay, now it's mapped. It's super easy in Ableton. And now let's try to do it. Okay, so it's going super slow, so let's hope. Oi, sorry. So now we can control this parameter from here with the LTR. So if I just close the box, now it's going super slow. It goes higher, okay? And now and then if I open it little by little, this number goes down. Okay, so that's what we are going to try to do now, step by step, and hope the laptop can do it faster. Okay. Okay, and then we can add a lot of more different effects, no problem with that. So let's start from the beginning. I'm a little bit concerned about closing it because then Okay, so let me check the. Okay. So first of all, what we are going to do is to connect the sensor to the Arduino. So how can we do that? I mean, because here it was already connected. Okay, so there are a lot of different sensors, as I said before, and it depends on the sensor how you connect it. We chose LDR because it's quite easy to connect. So any problem you have with that, you can look for it in Google for this kind of schematics. They're super simple. These ones at least. So it says, okay, you have this sensor, and what you have to do is to connect one of the legs to the 5 voltage one, and the other leg you have to connect it to the A0. A0, it means analog 0 input, okay, because we are going to work with analog. How do you connect it? Actually, there are different ways, okay. You can connect it directly here, as you see in the image, okay, but you will need this kind of cables for the Arduino. So yeah, so what you have to do, this kind of cables, okay, what you have to do is to solder, or just to, if you have good ones, for example like this one that you can connect it already because they are female, it's okay. So you connect it here and you go directly to the 5 voltage pin in that you have in the Arduino. The other one go to the A0, and you have to be careful with this one, the resistor. There are a lot of different ones. Here, for example, I can show you like a box with a lot of different ones, because it depends on the resistor you choose. That your signal is going to be good, or maybe it's going to be too weak, okay, so you have to choose the right one. Of course, we're not going to be a professional in electricity, but we can choose in the internet always, like, okay, I bought this LTR, which one is the best for it, okay, and we choose it and we put it in between the other leg and the ground, and that will be all. I mean, this is already connected. Of course, if you cannot connect it directly, you have this other possibility. It's a breadboard, it's this thing, okay. This is just to avoid to, okay, let me show you the full camera. Okay, here. This is just to avoid to solder a lot, okay. You can do your project here, and if it works, then you can be worried about doing it properly, okay. Then the final one, of course, is going to be soldered somewhere, and it can be, okay, much better. But to start with, we can start with a breadboard. Instead of soldering, the connections here are quite straightforward, because all the vertical lines, they are going to be connected, okay. So if you want to connect one leg, for example, to the red, what you have to do is to connect the leg in the same row here than the red cable, and that will be already connected, so you don't have to worry about anything else. So you do the same schematic we saw here in the PDF. You can do it here in the breadboard. These ones are really simple. Then from the breadboard you go to the Arduino, so you connect here, as I have it connected, the 5 voltage to the one that it says 5 voltage. If you don't have the names in the Arduino, because you, for example, bought a cheaper one, as I said before, you can look for your Arduino or your Beleman in internet, and you have all the names. So you just have to be careful that the voltage one goes to the 5 voltage, the round to the round, and then this one are the inputs, okay, like A0, A3, and they are okay, super nice. You don't have to do anything else. So this is hardware, actually. This is the only part about hardware, about doing the cable and the patches and everything. When this is already done, you have to focus in, okay, how can we code it? So we connect with a USB the Arduino to the laptop, and then I switch to screen camera just for you to see what we're going to do. Okay, so here in Arduino you have to open this software. It is called Arduino as the hardware, and you have to code to ask for the data of the sensor you connected. Okay, for us it is going to be super easy because we just have one. Okay, but let's do it correctly. I have this one, but you can also go here in File in Arduino, and also if you go to Examples, okay, in Basics maybe, yeah, Analog Read Serial. Let's wait for it. This example is super nice because it's only, if you check it here, it's super similar to the other one. Let's maybe use this one, that's the example of the Arduino. So the only thing you have to be worried about is to learn the number you're going to put here, the serial begin, because we are going to use it later in maximum speed. And then here you see integer sensor value. Okay, so here you are going to get the sensor value. You have to put analog read, as I said before, because we are reading analog sensors. And here you have to say the input. Do you remember when we said, okay, connect this to the input A0, analog 0. So here you have to put analog 0. If you connect another one to analog 2, no problem. You can put analog 2 here, okay? So, for example, like that, okay? For now, let's leave it in the 0, 1. Then we ask for it like serial print. So this is going to print the value. And the delay, this is more about coding, because this is going to create a loop, as it says here. It's going to ask for the value every millisecond. So here, if you have problem like overload or anything, you can put it a little bit higher. Of course, not to wait 2000 milliseconds because then the signal is going to be not really good. But yeah, okay, with 1 millisecond, let's try now. So what you have to say is upload it. This is going to upload the code to the Arduino, to the hardware, okay? So there is a step before if you want to do it correctly. It's like verify. This will say if the code, it is correctly done, okay? Of course it's going to be correct because it's the code of the example. So now we say upload. We wait for the code to be uploaded. Nice. Done uploading. So now suppose we have the code inside here, okay? We can actually just quit the Arduino software, because this is only just to design the code and to upload it. Now the code it is here, and we can connect this with USB to another computer, and the code is going to be already here, okay? Anyway, it is super useful here in Arduino that you can go, as we said before, to serial monitor, and this will show us the data we are getting, okay? This is kind of matrix thing, but yeah, you can see all the data running, okay? All the different numbers. For example, if it is super bright, the room, I mean it's not super bright, but if you just put the hand on it, you see the numbers go down, okay? So the darker, the less data you are going to get. If you just close the box, it's going to be around 100. If I open it, it's going to be about 950. Nice, okay. So what do we do with all those numbers? So first of all, we can even close Arduino, because it's getting, do you want to change? Yeah, okay, why not? Okay, so let's close it just to save a little bit more. No, okay, no, come on. Okay, let's quit. Arduino done, actually. So just read the birds in the background. Okay, so next step, we go to max MSP, and then I have prepared here a patch. It's going to be useful. Recent one, max patch, read sensors. This program, this software is also coding, actually programming, but it is a little bit easier than Arduino. Of course, you can do in Arduino, you can do all the coding to have like a super nice signal. You can also scale the signal there, all this number, for example, from 100 to 900. You can put it, okay, I only want it from 100 to 200. Okay, of course you can do it in Arduino, but that's a lot of coding. If you are familiar with coding, it's okay, but here it's more visual in max MSP. You can learn it faster, and for me you have a lot of more possibilities. We're going to see just the simple ones. Okay, it's about the scaling. So again, this patch, I'm going to upload it for you, so you don't have to write all these things. Just open the patch. Okay, first of all you have to unlock here. Hope you can see it. Okay, here in the down left corner, unlock it. Okay, so now we can move things around. Ooh, it's going slow. Okay, so what do we do here? Maybe with a command or control you can open the different objects. This is called objects, or these boxes that are connected, and this allows us to get the data and to play a little bit with that. So first of all, the third port is, okay, where do you have the Arduino connected? I'll have a lot of different ones here, you know, it's USB connections or Bluetooth, but the connection I have from the Arduino, it's the USB modem. Okay, so I choose this one, and then the baud. Do you remember the number set we had to remember from the Arduino? It was 9,000. Wait, 9,600. Okay, so this is all we need to tell max MSP to read the data from the Arduino we have connected. Okay, so it should work now, so we can close the log here and say open it. Okay, so we open the flow of data from the Arduino. These objects, serial, select, 10 and 13, set, L group, these are objects just to clean a little bit the data from the Arduino, because of course we are in a basic workshop, introductory one. We're not going to focus on the objects from max MSP, but actually if you just have this patch, you don't need to know exactly what they do. Okay, this is kind of a main object just to get the numbers here. Okay, so here we have the same numbers we got from the Arduino in the Arduino software. If we do the thing with the sensor again, you see that the numbers go down if the space is darker. If you go up, it goes up. Okay, nice. This unpack object, we can see it later. It is just in case you have different sensors, so you can work with the different data of the sensors. Okay, now we just have one, is more than enough to start with. So the data goes here, unpack. Okay, so we have to get the first data in the left. It goes here again. This is just another box to visualize the data. And actually we can go over. Wait, this is slide object. Okay, this slide object is just in case you have a data that fluctuates a lot, so it has a lot of noise, you know, like it jumps, for example, like that, you know, only by itself. That's if I just leave it like that instead of being around 950 something, it goes down and up a lot. So that's going to be a problem later because you cannot really control the sensors, okay? So this slide, if you have this kind of like super noise data, you can clean it a little bit. That means that when you go 5, it's will do a little bit of delay in the signal, so it's a nice way to clean it. It's not mandatory to use it, of course, but it's always nice to have this kind of slide 5.5 or something like that. Then here you have the data after this small cleanup of the signal, and this is the super important part. Let's do a zoom. Okay, here you have a scale object. What it says is that I'm going to get my signal is going from 30 to 900, but I don't want to work with this number. Actually, what I'm going to scale it is to get MIDI numbers, okay? MIDI always goes from 0 to 127, so I can say my minimum signal is 30 and my maximum is 900, okay? So I want to get it the other way around. So the minimum 30 is going to be 127 and the maximum 900 is going to be 0. Okay, how do I know these numbers? Because we are working in my house here in Malaga, maybe it's super sunny, so we have a lot of light, but if we go to a concert, these numbers, they're going to be lower. So what we have to do is to just see the behavior of the numbers and to put it in the space with more light, and then just do this total black, okay? Now we can see that actually the lowest one is not 30, it's more around 40, okay? So I just change the number 40, maximum 960, okay. Okay, so now I can, okay, it's around 40 and to 960, and then I put it the other way around. Why? Actually, if we see it here, when it is completely open, it's 900 and something, it's going to be 0. Okay, this slide is again the same object, okay, to clean the signal a little bit. It's going to be 0. Here you can see it like a fader. And if you close it little by little, it's going to go up. Why? Because I thought, let's do it with a reverb. And I thought it's going to be more usual, you know, to have a lot of reverb when you close the space. So it's going to be like a cave. And then when you open it, you don't have reverb at all, okay? This is invert scaling, but of course you can do it however you want. If you have a proximity sensor, for example, maybe we can use it later, okay? This one here. Whoopa. This one here. Whoa, wait. Sorry. Whoopa. Sorry for the camera. Yeah, this one is a proximity sensor, okay? So you have to check the signal with your sensor. If it is about proximity, you have to point the farthest point of the room just to get the maximum and the minimum the other way around, okay? So you have to do some tryout because it depends on the space and also the temperature, a lot of different things. So it's just good to try it out every time you're going to use the sensor. You just do the scaling, so nice. We have the data going up here. If we close it, it's going to go up, not to the maximum actually, because it's not completely closed. So now we have the fader here, the MIDI numbers we can map. How do we send it? There is an object, this one called 𝗘𝘅𝘁𝗿, okay? And this will send our MIDI data. What we have to do is to click over it when we lock the patch. Okay, and here you will have to choose the MIDI bus, the channel you want to send it. Of course, I've created a lot of different ones for different works I've done. But usually it depends on Macs and also on Windows. You will have one or two from the computer. Windows, maybe if it's going to be complicated, maybe you have to download a software to create this MIDI bus. But in Mac you already have it, okay? It depends on that. But we can work with the bus we want, okay? For example, I'm going to work with this one from Max 1. Okay, so now I'm going to send, actually I'm sending already all the data to Max 1. Okay, so time to go to Ableton. We open Ableton. We did this thing before, so maybe just talk a little bit about Ableton first. Ableton is a DAW, a digital audio workstation. You can get audio in it from your sound card, and then you can mix it and you can process it and do a lot of different stuff, edit it. Okay, so we are not going to go super deep in the software, but I will let you know what you need to know to make the sensor work as a MIDI controller. So you go here, live preferences. Okay, you go to MIDI, okay, and here in MIDI you have all the different MIDI ports. The only thing you have to be worried about it is that your MIDI port, the one you chose in maximum speed, ours was max 1, it's on, okay, in track and remote. So if it is on, it should be working. How do we know it is working? We go here, right top corner, okay, and we have a yellow square here. Okay, what if you have this yellow square going on? That's a good thing, because that means you have MIDI coming to the computer. Nice, okay. So what's next? Maybe let's check if we have sound. If you have, for example, a saxophone or a guitar or whatever instrument you are going to use to do this, you have to check the input channel, okay? So you go to one of these track, audio track, not MIDI, okay? Audio track, and here you can check the different inputs, okay? For the audio inputs, you just have to go here, live, preferences, audio, okay? Audio input, I'm using a Scarlett, so I choose my input device as a Scarlett. This is the sound card I'm using, okay? Here you can see it. Okay, so I have two different mics connected. This one, the second one, is the contact mic I'm going to use to do the sounds, and this one is just the mic I'm using to speak here, okay? So audio input device, Scarlett, and audio output. Now I'm using the external headphones. That should be okay. This is more about the quality and the samples. This is important if you're going to do something live, because it will change the latency. So the time it will pass between you make the sound with your instrument and you receive it from the headphones, or you receive it in the monitor to amplify it, okay? So if you want less latency, this is going to be like a delay of 14 milliseconds. Actually, they say 7 milliseconds is the perfect thing, you know, like lower than 7, but 14 is not, it's not bad. If you want less, you can say, okay, and also you can change the samples, the buffer size, sorry. So if it is go higher, you will get more latency. So if you want less latency, you go down in samples in the buffer size. But of course, the lower you go, the less sound quality you will have, okay? So that's all, okay? Input configuration, if we have a sound card with more inputs, 3 and 4, 5 and 6, we can select them. For now, we're going just to stay with these 2 inputs. Okay. So we have the software already. Now we go here and we say we want to get this sound from the input 2, because the input where I have connected the contact mic. Okay, so now I get the sound. I'm going just to do a tryout. Okay, I'm getting the sound here, but of course I'm not getting it in the master, because all the sounds, they go to the master. So I just need to the master on. Okay, and now we will listen to it. Okay, we have the dry signal. If you want more volume, you can do it here, or in the input of the sound card. I'm not going to go deeper in the sound card things, because that should be another workshop. So for now, I think we are okay. We get the sound, nice. So what do we want to do with that? Okay, we have a LDR, that's a sensor. We can use it to control a sound effect. So as we said before, let's do the reverb thing. So we go to audio effects, we look for reverb, for example. Put it here, we have the reverb. Okay, in the reverb you can control a lot of different parameters. Here now it will sound like a reverb. Okay, you can put more decay time, so it will last more, you know. Okay, and dry and wet, it's how much signal you have from the original sound of the microphone and how much signal you have after the effect. Okay, we will leave it 55 for now. So this is cool because you can create like a no reverb space, super dry, or you can create super reverberant. Okay, so we want to control it with the sensor. Okay, this open and close. How do we map it? So here in Ableton, that's why I usually recommend this software to do it live. It's super easy. You just go to the top right corner here, MIDI. Okay, and you say MIDI. Now everything is going to be blue. Actually, not everything, only the things. You can map it, you can control it with MIDI. So what do we want to control? I want to control the amount of decay time. Nice. So I just press it, bling, and it will appear MIDI from channel 1, port 1, and everything here. Okay, this is the sensor I'm using. You just go here, switch it off, and now we have it mapped. Okay, now the box is open. So as we said, it's going to be inverted. So if we have a lot of light, it's going to be the minimum. If we have like darker space, it's going to be maximum the decay time. Okay. Important thing about the effects and MIDI. Now we are working just with one sensor, but if you are working with different sensor, we can do like a tryout later. Oh, slowness. Max. You have to be careful about map the MIDI little by little. Okay, so imagine we have another sensor. So if I want to map a second one, we just say here, for example, none. Okay, and we activate the other one and we say send from max. Okay, so now we activated this one and we should go again to Ableton. Okay, say MIDI, and now, for example, you know, here now it's not moving, but we can fake it because we don't have another sensor connected yet. So I just move it here, my hand, and now, as you see, you have the other one connected here. Okay, the third sensor. This is super important, because if you have everything open in Max, then it will be a mess, because if you want to map it here, it will map the sensors you had open before. So it is better just to be patient and to do it one by one, switching here on the sending and off every time you want to map one of them. Okay, for now we're going just to eliminate that, escape, and you just take it off. Okay, so now we have it mapped. Let's try it. So okay, you have, and now wait, sorry. Same problem, you have to open it. Yeah, I want to send it from Max now. Okay, so let me check. Okay, so now we open it. I mean, of course, super simple, you know, the sound effect, but it becomes super physical. Okay, if I just I mean, it's super simple. Okay, it's just like a contact mic connected to a box, and then you have here the sensor. So you can play a lot already, you know. You have like a box, but with a bit. You can even like. So you have like a lot of difference between, you know, and also it's super nice because you have a direct control one-to-one to this, so you can play a little bit to control it, you know, like I want 5 of time decay, 5 seconds, and I want to go more, so I close it. Let's put it a little bit more here. Okay, now I want to go to dry. Okay, of course you control whatever you want. Now I think it's a good time just to explain that you can do a lot of different mappings. So if we go here and we look back to what we've done until now, let me put the screen sharing. Okay, so we connected the Arduino, the sensor to the Arduino with the breadboard and everything. Then we did the Arduino code, the simple one, okay, and we got the numbers from it. Later we can try to do these 2 sensors example, okay. Then with the data, we went to the maximum speed with the patch. I'm going to pacify, and then we get the data into the program. These objects, they are not important for us, at least at the moment, but we have to choose here the port of the Arduino and to put the same value here that we put in the Arduino code. Remember, it was 9600, that's the usual one. So now we get the numbers here, we unpack it. If we have different ones, we can put a little bit of clean up the noise with this slide, not much, okay, if we don't really control it. And then we scale it, that we had a signal from 30 to 900, and we want it to be from 127, because that's the maximum of MIDI controller, to 0. Okay, slide again, we get the signal here, we have the fader, and we send it with CTL out. Okay. So after that, we went to Ableton. We chose the MIDI preferences. Okay, that's we want to activate the max 1 sending. And here in the template, we chose the input we want from the sound card, and we chose all the effects we wanted to put on this track. Okay, for now we just have the reverb. After that, we go to MIDI, and we select the thing we want to control with the sensor. Okay, so here there are different ways to do it, because we can control one thing, one parameter of the effect with one sensor. It is called one-to-one. Also, we can control many different parameters with one sensor. This is the usual thing in acoustic instruments. Actually, you have a bow, but with the bow, depending on how you're going to bow the strings, for example, in a violin, you are going to create a lot of different details, a lot of different parameters, dynamic, timbre, a lot of different things, only with one gesture. Of course, the gesture is going to be complex, but you are going to create a lot of different ones. So actually, it is more usual to create one sensor that map many different parameters. Okay. There's another option. It is called many-to-many. So you have lot of different sensors and you control a lot of different parameters. This one, the last one, is not so much used, you know, like you have a lot of different sensors and you just control one. For example, you have like LDR, and also you have, I don't know, proximity sensor, but you are just going to control one reverb, you know. Okay, it can be useful, but it's not super common also with the instrument. So for this point, what I can do is, okay, so let's go to max, and we say our sensor is going to control not only one parameter but two. Okay, so for that, from this number we create another link to a different scale proportion, because maybe we want to scale it different. Let's say, for example, I want to add an effect only when the LDR is in maximum. Okay, so we just say here, okay, I want to scale it, but not from 40 as before, but for 100. Okay, 400, sorry, to 900. Okay, and it's going to be a direct relation. So when the sensor is 400, you're going to get 0. And when the sensor is 900, you're going to get 127. Of course, in Max, you can learn how to do it exponential and a lot of different things, but let's go little by little. So now you have different parameters here. You can check now when I do this with the, I can put it a little bit bigger. Whoa. Okay, so box closed, no light. Then the reverb, this one, the one we did before, is going to be maximum. This one is going to be minimum. But when I open it, there is a point when the numbers of the sensor lights is 400. It's going to grow a little bit. Okay, so okay. So this could be nice. Actually, I don't know what we are going to do with this one, but now we have two controllers. So we have one sensor, one number, but this number is going to go to two different mapping. Okay, so if you remember what we do now we have to lock the pads, and we say, okay, switch off the one before, and I'm going to switch on from max one, this one. Okay, so now I have another parameter. Let's do it again. Let's go to Ableton, and let's choose another thing. I don't really know what. You can go here to effects just to try out. We can put a beat repeat, for example. That could be nice. So variation 0. This will do like a repetition, like random repetition of what we do in the so let's try it first if it works nice. Wait, volume. Actually, it's going to be maybe an erosion is going to be more obvious now. Okay. So what can we say here? We have this kind of effect and we say, okay, I want to control the amount of this effect with the other parameter. Okay, so we go to MIDI, we go to amount. Now it is done. Okay, here you can see controller 1 is for the reverb, decay time and minimum. You can also scale it here. Okay, I prefer to do it in max, because then if you scale it in max and then you scale it here, it can be a mess, but you have also this possibility. Okay, and the amount of the erosion is going to be 200 and 0. Okay, nice. So now we have it. We have to remember to go here and switch on the one before. Okay, now we have both of them working. We have to put the reverb. Okay, so now, for example, reverb now is maximum because it is closed, and the amount of erosion is minimum. Okay, there should be a point here. That the erosion starts to go up. Okay. Now you say maybe it is a pity that we cannot listen to the erosion. Maybe let's put this one first. This is the path of the audio. Okay, the audio goes in here and it goes out here. So just put the erosion first. It is a pity that we cannot listen to the reverb of the erosion because it goes up when it is in the middle. So no problem. We go here and we say, okay, I want to scale it that it starts a little bit before. So here in the scale I say, okay, maybe not 400, but 200 maybe. Okay, so now we have a little bit more. Now there. Okay. Okay, super erosion when it is open. This point here is quite nice because we have a little bit of erosion and we have a little bit of reverb. Now super reverberant with no erosion. Okay, of course we can spend all the day here adding effects and mapping, but I think it will be more useful just to think about, okay, I have another sensor and I want to have two sensors in my instrument. How can we do it? Let's sorry. So there is a good option, an easy one is, for example, this one is the IR sensor. Okay, so I'm going to, IR sensor is proximity sensor. Okay, I'm going to connect it as it says in the internet. It has 3 different cables. So one cable is going to be for voltage, the red one, the other one for ground, the names in the Arduino, as you remembered, and the other one is going to be the input of the signal. So I'm going to connect it to A2, for example, analog input 2. Okay, here in the analog you have an analog input 0 and an analog input 3. Okay, actually 3. Okay, so let's do it on 3. So we connect it to the Arduino, and we have to open the Arduino coding again, because we have to change the code to tell the Arduino we want a second sensor. Here I put you an example of how we do it. It's super simple. We just add a new one, okay, analog read A3, and then it is important to put this space here, like serial print, commas, space, because we will have the numbers into different columns to separate the signals. And then we just say, okay, serial print again, line, this is a different one just to separate them, the second sensors. Okay, that's what we have to add here and here. So let's do it. Arduino, nice. Went too close, sorry, the children's. Okay, so here we say, okay, we want sensor value, but we also want a second one, right? Okay, and it's going to be the input 3, as we said, analog 3. Serial print, not only this one. Whoa, wait. Yeah, come on. Just copy it, please. Okay, copy it, paste, serial print. Come on. Okay, this is pasting. Super slow. Should be faster on your computer. Sensor value 2. Then the delay can be the same, actually. I mean, just we have to be careful with this point. Serial print here cannot be line. Serial print here cannot be line, and this one will be line. Okay, so we changed a lot of things, not a lot, but we changed things, so we have to check if it is going okay. Okay, done compiling. Okay, it seems it's okay, so let's upload it to our Arduino. Oh, wait. Good thing that it happened, because it's good to know that in Macs I recommend to have this close, okay? And then in Arduino, we didn't say much about that, but we have to choose the port we're using. The Arduino Uno is my case. Later we can see a little bit of this one, the SP32, because it allows you to have internet connection. And here the port we're using, okay? In my case is USB modem. Now it should work. Nice. Okay, so now we can check if we get the signal. Nice, we have the two columns. So one will be the LTR, this one, the first one. Okay, so if I open and close again, the wait. Oh, doesn't with the camera. Sorry. Okay, there it is again. Okay. So if we open and close, these numbers go up and down, and then the second one is the new sensor. This one, okay? It's a special one, okay, because okay, let me okay, this one. I don't know if you see it in the, I will put the other camera just to be clear. Okay, so you have the other sensor, it's already connected, it's getting data, so this sensor is proximity 1. This one is not useful here in my room because it's small and you need at least like 10 centimeters from it to work properly, okay? But we can do some games with it, okay? So now we get the data, we go again to Arduino, we close the monitor, we can close Arduino program. It's going to say if I want to save. Actually, I don't want to save it because I already have it in my Arduino. So don't save. Okay, so now in Max, now we should have two different inputs, okay? Again, USB modem, because this is my port, about is 9600, open. Magic happens. We have the same number for the LDR here, but we have a second number. This is the number of our new sensor. Now this object becomes super important because we unpack this number and it goes here. Second numbers, it goes here, okay? And now we can also scale it and do all the stuff we did before. We're going to do it faster. So here we have to see, okay, let's put it a little bit more there, like which one is the highest one. Okay, I think it's around 400, and the lowest, I mean, it's proximity sensor. We don't have a lot of space here, so it's not going to be super high. Yeah, but around 150, I think. Okay, so again, my minimum is 150, maximum around 400. I want it from 0 to 127. Okay, so we have it here. Okay, now it's maximum, and now shoom, goes to minimum. Okay, another sensor. What do I do now? Again, I go to Ableton, I just switch off this. Come on, come on, come on. None. None. This one from max 1, perfect. This one, no, I don't want it. Nice. So now I have just one open. I go to Ableton again, and what do we do now? Actually, I don't know. Let's do this kind of resonator things. Okay, so I put another effect, and I want to control how much dry signal or wet I get it from it. Okay, for example, from the resonator, let's put the volume up again. Okay, so I have a resonator. Shoom. With the reverb, so I say, okay, go to MIDI, and I want to control the dry and wet. Done. Super nice. Here, for example, I want to say maybe I don't want like 100% signal, okay? I want 60% of the resonator. So I can also choose it here, okay? My maximum in Ableton is going to be 60. Also, I'm sending 127, that's the maximum MIDI signal from max. Okay, so now we can control it. Do you see that with the sensors? Okay, I can move it. Of course, this sensor, you have to be more careful with this. Okay, so let's put all the sensors together working. So we go here and we say, I want you. I want you, also you. And here you have everything working. Okay, have decay time working, the erosion working, and the dry wet. Okay, so just let's play a little bit with this, see what happens. Oh, sorry. Sorry, I should put the other camera. Okay, there. Okay, I think you can even see it better with the other camera. So let's do a final. Come there. Okay, have it here. You have the contact mic. There you have the LDR. Here you have the sensors. Okay. So yeah, so I mean, you have now like a lot of different options. Of course, we can spend time like doing another one, like for the second sensors, you know, and control it and send it. This can be like a huge patch. Okay, this is just the beginning. I can send it to you, so no problem with that. Actually, maybe we put a link for you to download it. And actually, that's all you need to know just to get your sound and to put effects on it and try to control it with different sensors. Of course, this is going to be an extension of your instrument, so you also need to control it properly. You, of course, we did just as an instrument in half an hour, maybe 40 minutes. So now should be the time to, as I usually say, to work with that, these loop of rehearsals. Okay, this is my workflow. So what I usually do is like imagine something in tape, like electronic, not lives, and then I think, okay, how can I create this electronic piece or to give it a little bit more with live control? Okay, so I just think about one gesture I want to use, for example, the movement of a clarinet up and down. And then I think about what sensor I have to use to have this embodied electronics. And this I tried a lot with improvisation with the performer, or if it is my instrument I try it. So I just scale it properly and do a lot of different stuff to the data to be smooth. And then this is more about composition. So with this I go to do the form of the piece, you know, like I will do this first, then do this, then do that. And then after all this trying out, I do a score, or we do the performance, okay? But it's super important, this loop of rehearsals, because you created a new instrument or embodied controller, so you really need to get the control of it, to know how it works, the subtle things you can do with that and everything, okay? Just to finish, I wanted to say that you can do a lot of more stuff, okay? Of course, you can do another option. I don't know if you know 𝘊𝐺𝗃𝗁𝗁. He's like super good electronic luthier, I don't know how you want to call it, and composer, and he did a lot of installations. And he used this ESP32, okay, instead of Arduino. And this will allows you to use internet, so you don't need this USB cable connected to the computer. You can do it only with Wi-Fi and internet connection, so you don't have to get the laptop next to you in the concert. Of course with sensors, as we said, you can try a lot of different ones for your installation or your performance, and you can choose in between all the different things you can measure. And think about that, like, okay, what do I need? Like, do I want to do a piece about weather? Okay, let's use wind measure sensor, you know, for example. Arduino Code, as I said before, it could be improved, like to get a more smooth signal, a stable signal. And also, of course, you want to use like gyroscope or accelerometers, you need a more complex code. We cannot deep on that now, but GitHub, for example, it's a good way to get new codes and to try them out. And if you want to go professional with that, you have to learn to code in Arduino, of course. In Maximum Speed, the program of the data, you can explore new objects that allows you for more information in your data, or you can use, of course, 𝘀𝗏𝘁, okay? Instead of MIDI, you can use 𝘀𝗏𝘁, so you have a more range of steps in your signal. Actually, it's more professional, okay? Also, all the people, they start with MIDI. And in Ableton Live, you can explore all the different effects library and found the new possibilities. Like if you go here, you go to all the audio effects, you have a lot of different ones here, libraries. And you can always, if you are tired of these ones, you can download your plugin, your VST, and to add it here, and you can learn how to control it with sensors. Okay? Actually, that's all. If you have any question, you can let me know, okay? And Vitaly asked, what kind of sorcery is this? What red workshop? The only thing is, I mean, to get familiar with the three different programs, okay? With Arduino, don't go really complex with that. Just use the simple code to get the data in Max. Max is a object-oriented program, so you can get easier, like more kind of data, and to map it properly. We will upload this patch too. And with Ableton, it's really straightforward. If you have a controller, like a MIDI controller, like a keyboard, it's super similar. Only be careful about switching on and out here, just to don't mess around, because as you can see now, all of them, they are working. So if you start to map the MIDI in Ableton, you cannot really differentiate, like I want this one or this one or this one. So it's better at the beginning just to say, okay, here, none, and then just put this one and the other one. And that's all, actually. I mean, hope. Okay, I hope it was useful for you. And of course, if you have any doubts or you want to learn more, if you see it later that you are not online, you can write to me here in juanlumontoro.gmail.com. Also, you can go to my website if you are interested about what you can do with these kind of sensors. And thanks for watching, and hope you send me your results of this workshop. Bye.